Okay, children. Spectrum chapter. In chapter 4, we studied about the deviation produced by a ray. That time, the incident ray like this, when we took, that was actually containing of one color. We were not mentioning exactly, but in some questions, it was mentioned also a monochromatic ray of light. So it was written a monochromatic ray of light. Mono means one. Monochromatic ray of light means the ray which consists of only one color. It may be either yellow, or it is green, or it is blue, a single color. So in all the experiments or working that we had done till now in chapter 4 and chapter 5, we were dealing with a single color, a monochromatic ray of light as the incident ray. Is this point clear? Though not that time we emphasized on it, but now I'm telling what we had been doing was of a single color. Okay. In this chapter, we are going to learn about white light. White light means the light which comes from sun, stars, etc., bulb, etc., which is composed of 7 colors: violet, indigo, blue, green, yellow, orange, red. Okay, so let's just go back. The difference let us discuss. Then we come into the actual white light and its spectrum formation, the dispersion, the phenomenon, everything we will discuss. Okay, in chapter 4, we studied about the deviation produced by a ray of light. Deviation means what, children? Deviation means from the actual course of the ray, because of the prism is present, the emergent ray goes in a different direction. And this happens due to first refraction on the first phase AB, first tilting towards the normal. Then again therefrom it was moving, it was emerging out. Again a refraction was taking place. So the emergent ray when produced backwards, incident ray when produced forward, they form an angle. That was angle of incidence that we had discussed. The amount of, or we say the value of angle of deviation produced by a prism depended on 3 factors. This also we studied. I'm just recalling in chapter 4, the factors that affect for the deviation of a ray that incidents on a prism, we studied that depends on the angle of incidence. Here it is the angle of incidence, no? Incident ray and normal, what it is forming the eye. Here, I'll do it with a different color, children. This is eye. This is eye angle of incidence. Okay, this angle of incidence, if we are, and we had seen what is the dependence. It is angle of incidence and deviation produced is varying, and it is first decreasing and coming to a minimum. Then on further increasing in angle of incidence, it is increasing the deviation. This is what was seen. So, okay, so it depends on angle of incidence in any case. Then angle of the prism. The second portion is the angle of the prism. In this prism, 60 equilateral prism I have taken. So it is 60 each is the angle. So more the angle of the prism, more is the deviation produced. And third was refractive index of the material of the prism. With what material or what type of glass, flint glass or rocks, salt, prism also, what is the material we are making this prism with. So depending on that also it is varying. Angle of deviation is varying. Now, again in chapter 4, one more factor we studied, the refractive index. Refractive index means how much it bends towards the normal. Depends on the color. That is the wavelength of the light incident on it. And we know for which color the refractive index was more. Anyone knows? The refractive index mu for violet is more than that of the refractive index of red. That is why when a ray of light, that means the dispersion, that time itself this diagram I had shown, the deviation produced by violet color is more than that of red color. Deviation produced, because here the angles are mentioned. At this phase AB, the white light which is incidenting. I told you white light is composed of 7 colors: violet, indigo, blue, green, yellow, orange, red. Out of which violet has got the wavelength, the lowest wavelength, that is 4000 angstrom. In terms of angstrom, if you say it is 4000. If you say it in terms of nanometer, it is 400 nanometers. While that of red is 8000 angstrom, or we can say 800 nanometers, where 1 nanometer is equal to 10 raised to minus 9 meter and 1 angstrom is equal to 10 raised to minus 10 meter. Okay, so rays of light coming from sun. First, let us discuss what is spectrum, then the deviation, why the spectrum is forming, that is what we can discuss. Okay, rays of light which are coming from the sun, in incandescent bulb and star, etc., are actually white light. They don't have any specific color. The white light is composed of 7 different colors of different wavelengths, and the colors are starting from violet till red. In between, which are the children? Violet, indigo, blue, green, yellow, orange, and red here. Okay, so we call Vibgyor colors in short. Violet, indigo, Vibgyor, Vibgyor in short form we say. Out of which violet has the lowest wavelength and red has the highest, and all the others are having intermediate values. And what do you mean by wavelength? We can have a look at, children. The wavelength means one crest and one trough. The horizontal distance for it. Horizontal distance for, or we say 2 successive crest, one crest and second crest. What is the distance between them? This also we can say as the wavelength. And when you consider in these diagrams what I've shown, the waves of different colors I've shown, you can see the violet is having a shorter wavelength from here till here. A shorter wavelength only it is having. One crest and one trough. Yes or no? While that of red is having the maximum. Okay. And the other colors are having in between. If you show the values, the red end has got the maximum 8000, but it begins from 6200 nanometer, angstrom till 8000 angstrom. While violet end is from 4000 angstrom till 4460 angstrom. So in between, maybe some 500 or 800 angstroms, the range is for one color. Okay. Now, why this happens, the splitting of light, that is what is called dispersion. A new term we are learning. When a white light, which is having all the 7 colors in it, I mean to say, this white light is actually composed of a violet color, then an indigo. Indigo means a kind of deep blue color, children. Okay. Violet is there, indigo is there. They all are bound together as all their velocities are the same in white light. Okay. Only the blue end I have done. Now I just completed with the orange and red. Orange and red. So all these are coming in the same wavelength. In air, all the 7 colors have the same wavelength. So the reason why they are forming, they are getting separated by a prism is because of this reason, that in air, all the colors, this violet till red, all the Vibgyor colors have the same wavelength. Same wavelength means they all have the same speed. So they all will move at the same speed and they all move together. So there is no separation we feel. So in air, when we view them, we feel they are the single color, that is white light. Okay. But when it strikes at the surface of a prism is made of glass. Glass has got the refractive index, a property, and because of which it will bend the light which is falling on it. I told you in chapter 4, we took only one color. So its angle of incidence, whatever is the angle it is forming with the normal, towards the normal, it was bending inside the prism we were seeing. But in this case, the 7 colors all have different wavelength in the second medium. All other mediums, the light has got the different colors have different speed. So violet, since it's having lower wavelength, will move with a smaller speed, while red with a larger wavelength move with a larger speed. So red color will move in this way with a larger speed, while violet color will move with a smaller speed, and hence it will bend more towards the normal. More towards the normal means from the actual path it is deviating more. Yes, Elaine?
Yes, ma'am.
Okay, I'll show it with scale so that the understanding will be clear to you. Yeah, incident ray, incident white light I'm considering. Let's remove all these colors. Yeah, so a white light is incidenting here. Remember, it is composed of all 7 colors. As it is incidenting, it is actually moving in this direction. If this prism wasn't there, it would have gone in straight direction. When the prism is there, the different colors since have different wavelength. Red has got the largest wavelength. So it bends from that white light's direction. It bends this much. So the red color has the largest wavelength and among all the 7 colors. So it will start moving in this direction. Let me take red color only. Yeah. So it will start moving in this direction. Only this much it will be bending. While the violet color has got, the rest all colors are in between. Violet color has smaller wavelength. So its speed is less and it will hence bend more from the actual path of the ray, that is the white light's path. May say this will be bending now more. So the violet color will be now directing to the other side of the prism in this direction. Okay, in both the cases, they are bending towards the normal, but the refractive index of violet is more. Because of that is more, what will happen? It will bend more towards the normal, and because of which it produces a large deviation. Okay, now they have to emerge out. Remember, the red light was coming in this direction. Again, when it is entering into air again, it is getting away from the normal at that place. Okay, so it moves maybe in this direction. The red ray will be moving, emerging out. Yes, Dylan?
Yes, ma'am.
This is the direction in which the red ray will be moving out, while the violet will be getting more deviated, more away from that. And the violet may come through this direction. Okay, now I drew it's a straight line, but they are in the form of waves, no? So you can see here from the actual white light's direction, see the violet is having this much angle while red is having a smaller angle of deviation. Do you understand what is deviation? From the original path direction of the incident light, the direction in which the emergent ray goes, that is how much deviated we are discussing here. They are to be marked with arrows. Now, in the form of waves, they will be coming out. So we are seeing, since the refractive index mu of violet is greater than refractive index of red, so the bending produced by violet is more. So violet color deviates more. Since they are having different speeds, they bend at different angles, they get separated at the phase AB. The AB side, they get separated. Children, this is the way they are moving. They all move from the same place. But since the speed is more, wavelength is more for red, that bends only little, while the violet bends more from the original path of the ray. Do you understand?
Yes, ma'am.
Splitting of white light by means of a prism into its component colors, this is what is called dispersion. This phenomenon is called dispersion. So a term dispersion, what is it? The splitting of component colors of white light when it is striking at the surface of a prism. prism being made of glass, it refracts, bends the rays towards the normal. And the colors, the component colors of white color, since they have different wavelengths, they will deviate at different angles, and hence they will be getting splitted up. So the dispersion actually takes place on the first surface, in this case at the AB surface. And it carries on when it strikes at AC surface of the prism. There it simply emerges at an angle, that's it. Do you understand now what is dispersion?
Yes, ma'am.
Okay. So dispersion in book, children, the definition is given. Please go through. Yes.
Yes, ma'am.
Deviation was discussed, colors was discussed, dispersion of white light, page 134, and the definition is in 135. Okay, I already mentioned what it is. Now the dispersion takes place only at the first side of the prism where the incident ray is touching. So dispersion takes place only at the first side, and